Question: 70 calorie of heat are required to raise the temperature of 2 moles of an ideal diatomic gas at constant pressure from 30 degrees centigrade to 35 degrees centigrade. The amount of heat required in calorie to raise the temperature of the same gas through the same range at constant volume is. So this question is based on two formulas. One is heat at constant pressure and another one is a heat at the constant volume. So we can use both the formulas, and we already know the relationship between Cp and Cv, that is equal to R. We simply substitute the values and we are going to get the answer. So let us start from the heat at constant pressure. Heat at constant pressure. Suppose that is given as Qp, which will equal N multiplied by Cp and delta T, where N is the number of moles, N is number of moles, and Cp is molar specific heat at constant pressure. Cp is molar specific heat at constant pressure, and number of moles is given to us, so let me write it here. That is given as 2, and delta T is the change in temperature, and that is our 35 minus 30, and which gives us 5 degree centigrade, and Qp is given to us as 70 calorie. Qp, it is given as 70 calorie. So from here we can, this formula we can find out our Cp. So therefore we can write that Cp will be equal to Qp divided by N multiplied by delta T, and substitute the values. We get 70, N is 2, delta T is 5, and this gives us as 7. Okay, calorie gram mole per degree centigrade. Now we know the relationship between Cp and Cv for a diatomic gas. From that we can find out our Cv. Relation between Cp and Cv for a diatomic gas. We can write that our Cp minus Cv is equal to R, and value of R will be equal to 2 calorie per mole and per centigrade. So we already know our Cp, so we can write that the Cv will be equal to Cp minus R. So we can say our Cv is equal to Cp minus R, and Cp is our 7 minus 2, so this comes as 5 calorie and per degree centigrade. And same formula, but now with respect to QV. So we can write that heat at constant volume if represented as QV will be equal to N multiplied by CV multiplied by delta T, and delta T, the range temperature is same given the question, so directly we can just substitute the values. We get over that QV is equal to 2 multiplied by 5 multiplied by 5, and this gives us a 50 calorie. And the option that are given to us, option number B, is the correct option. You can say option B is correct. So this completes the question. Thank you.